starting with the Ch.4. The script we built so far work when everything goes right, but real script get thrown at real systems, and real systems are messy. Files don't exist, arguments are missing, command fail, and by default base just stops and keeps running. Ch.4 is about writing script that fail loudly and correctly, run automatically on a schedule, and don't embrace you when someone else uses them. Three topics today: strict mode and debugging, exit code used defensively, and cron for scheduling. The chapter ends with exercise 7, a backup script that pulls together everything from the first four chapters. By default, Bash is dangerously forgiving. Watch this. Hmm. See that? CD failed with an error, but Bash just moved on. The echo ran in the wrong directory. In a real script, that rm command could have wiped files in any unaccepted location. One failed command silently corrupted the entire script logic. The fix is one line added right after the shebang. Set -e tells base if any command fails, exist with a non-zero code. Stop the script immediately. No silent continuation. Now the script stops the moment something goes wrong. The damage is contained. This is the behavior you want. Second flag, -u. By default, if you reference a variable that was never set, Bash quietly treats it as an empty string. With -u, it becomes an error. Without -u, if you mistype a variable name, say username instead of username, Bash silently substitutes an empty string and your logic runs on garbage data. With -u, the typo is caught immediately. The third flag, pipe fail. In pipeline, set -e only checks the exit code of the last command. If an earlier command in the pipeline fails, -e doesn't catch it. With pipeline, pipeline's exit code is the exit code of the first command that failed, not just the last one. Now the whole pipeline failed if any page failed. All three flags combined. This is the line that goes at the top. This is the line that goes at the top of every production script you write from now on. Right under the shebang, no exceptions. Like set-e, exit immediately on any error. Set-u, unset variable errors, and set-o, pipeline fail. Memorize this line. Put it in script. Put it in every script. Make it a habit. It costs you nothing and saves you more. Uh, it saves you from entire categories of bugs. Sometimes a command might fail, and that's okay. You can make append double standing line to tell bash. If this fails, treat it as success and continue. The hyphen P, okay, so the hyphen P flag on mkdir is the cleaner solution. It creates the directory and it present as parent is needed and doesn't error if the directory already exists. Use mkdir-p as your default. Even with the script, even with the script mode, scripts sometimes behave unacceptably. The best debug tool best has is the hyphen x flag. Race mode. Uh, it prints every command the shell executes with variables already expanded before it runs it. See the plus sign. Each plus line is a command base is about to execute with all variable are already substituted. You can see exactly what your script is doing at every step. This is how you find the lines that misbehaving. Sometimes the whole trace is too noisy. We only care about one section, one suspicious section. You can turn tracing on and off mid script with set hyphen x and set plus x. Three things to look for in trace output. First, check if variable expanded to what you expected. Second, count the commands. Are there more or few than you expected? Third, find the last plus line before an error. Test the command that failed. We touch on exit calls in chapter 2. Let's go deeper. Every command in Linux exists with a number. Zero always means success. Non-zero means something went wrong. And different number means different things. You don't need to memorize all of these, but 0 and 1 are in your and 127 command not found is one you will see constantly when a tool isn't installed or a path is wrong. With a strict mode, most failures stop the script automatically. But sometimes you want to check the exit code yourself and decide what to do. The slash dev slash null redirect. We are throwing away all of things output. Dev /dev null is the trace scan of Linux. Anything sent there disappears. We only care about the exit code, not the output. Here's a clever way to write it. In which, if the command succeeds, the if block runs. If it fails, the else runs. This is the idiomatic base way. You skip the dollar. Check entirely the command success or failure drives if block directly cleaner, fewer lines and same. For one-liners, two powerful operators, tuple, appearance and run the second command only if the first succeeded. Double pipe, run the second command only if the first fails. Double apply and chains are how offensive operators sequence recon steps. Only run the next tool if the previous one succeeded. When you write scripts that other script or tools will call, set meaningful exit code and always write error message to stderr, not stdout. V greater than and 2 redirects the error message to stderr. Error message belong on std error, so they don't pollute the data stream. When your script's output is being piped into another command. Okay. So what is Cron? Cron is Linux built-in task scheduler. It runs command or script automatically. At times you specify every minute, every hour, every day at 2 a.m., the first of every month, set it and forget it. This is how you turn a script into an always on automated tool. Every cron entry is one line with 5 type fields, followed by the command to run. Asterisk in any position means every 5 asterisk means run every minute. One asterisk in the minute field, and the rest field in means once an hour at that exact time. The asterisk slash far syntax in the minute field means every 5 minutes. The slash means divide, asterisk divide by 5 gives you 0, 5, 10, 50. You can use this in any field. Okay, so let's add a real cron job. We'll make it run every minute and write a timestamp to a log file so we can verify it's actually running. Let's wait for 60 to 90 seconds to show entries appearing. Okay, let's check the where it is. The cron job is running. Not double arrows happen to the file. A single would overwrite it each time. Always use double for log files. Okay, cron is three gold jars that catch almost everyone the first time. The 2 is greater than and 1 at the end is critical. It redirects std error to the log file as well as std out. Without it, errors silently disappear and you have no idea your cron job is failing. Okay, so to view the cron job, you do this and to remove the cron job, you do this. You are removing all the cron job, not specific. Okay, so exercise 7, backup.ssh. This is the capstone for the first 4 characters, that means first 4 chapters. So 6 requirements. Pause here. This one requires you to pull together strict mode, argument handling, $hash, command substitution, and tar. Give it a proper try before coming back. Okay, so the $hash holds the number of arguments, hyphen and e. 2 means not equal, means not equal to 2. $0 is the script name itself. Uh, Using it in the user message means it automatically reflects whatever you name the script. Learn variable for $1 and $2. Source and dash tell you what they are. Row $1 and $2 throughout the script count. The tar flags C creates Z compressive with TZ. V Berberus. F specifies the output file. Okay, so this is how the full script will look. You can check out. So we will test all the parts. So as you can see, I run the three tests. First is no argument, user message plus exit one. Second test is one argument, user message plus exit one. Now third correct usage is giving both the arguments. Okay, so we will start. The whole point of this script is that it's cron ring. Here's what a daily 2 a.m. Beckett cron entry looks like. Full absolute path. I will just show you the cron. Okay, let's me clear this script. And then now it will be visible. So full absolute path everywhere. Source destination in the script itself. Output redirected to a log file. This is a production grade cron entity. Okay, sorry. Input the cron valve. Sorry. Oh, here is the cron valve. Send this to relay from everything is okay, it is a system. Right, page. And then full absolute path everywhere. Source, destination, and the script itself. Output redirect to a log file. This is production grade cron entry. Okay, so chapter 5 API calls and JSON. This is where we connect our script to the internet. Call for making HTTP request, JP for passing JSON, JSON response, and chaining API calls together. In offensive security, this means automating Raccoon against web APIs, acquiring threat intel services, and building tools that pull live data from external sources. It's a step change in what your script can do. Exercise 7 challenge extend backup.sh to check that the source directory actually exists before trying to archive it. If it doesn't exist, print a clear error to std error and exist one. You have everything you need. Drop your solution in the comments. Subscribe for chapter 5. See you there.